Hey, how are you doing? My name is PJ Klimek. This name can translate very easily to different languages, PG, PJ, so it's easy. I work for Holo, which is the sister organization of Holochain. Holochain is the peer-to-peer distributed system which I'm going to be talking about. And Holo is the organization that's trying to build a bridge between the distributed web and the classical web, so that like typical user that doesn't know anything about cryptography could actually use distributed applications. But I'm not going to be talking about that. I'm going to be talking about the Holochain engine. So with each speech, I start from a different perspective. And this time I decided to start from the agent, where the agent is the person that creates data. So first, I was thinking that it would be good to say what is information, actually. Because we have to go very deep down into the roots of what the information is to understand how to handle it in the distributed manner. Then I'm going to talk about how the information flows between agents nowadays, which is through mostly Restful API and what's broken there. Then talk about the agent's ownership on information and show how it applies to design of Holochain. So what is the information? For us, it's a record of a change in status. In status of what? It can be a status of anything. It can be a status of my knowledge. It can be a status of where the parcel is traveling across the world. It can be the status of my banking account, right? It's the change in this information, in this status. And us at Holochain, we're trying to liberate the information. That's Holochain team. No, I'm kidding. But what we are trying to do is allow this information to travel flawlessly across the world without being constrained by the centralized organizations that always have an agenda. No matter what you think, they always have an agenda because they have access to all your information. So the way user, agent, interacts with the data through internet looks approximately like this. User interacts with the UI. This user interface has to communicate with some data. This data, for now, is stored locally, and then it has to travel across the networking to the central data storage. So this data interface can travel, sometimes can be more on the provider side, sometimes it can be on the user side. What's very important here is that there is a one central data storage. So whenever a user wants to interact with information, they have to reach out to central store. So, for example, how does the Restful API work? So those are different services. The user stores information in different online services, A, B, C, D, E, F, mostly F and G nowadays. And they can access that information through those portals, right? So they can access, for example, latest tweets, information that somebody sent them, messages. But what if I wanted to actually cross-reference information from different services? So for example, I would like to pull from F my favorite food that I was writing about for the last 5 years and see on G's maps where is this food allocated. Well, would I be able to do that? Unfortunately not, because although those services can interact, they exchange data between each other, probably secretly, and create profile on us, they don't allow us to do that. So what is happening, we are actually striped from the ownership of the data that we created. And well, if any of you is a programmer, you know that the APIs are very limited on any of the services that store data, and they won't allow you to access your own information. So what we are proposing is that we have to go back to agent centricity of ownership of data, which is the model, a little bit different than the one that I was showing. And it's the user interacting with through UI, through data interface with local data storage that communicates through the network. So what it is, it's a peer-to-peer model, right? And what is interesting is that that was the original design of internet in probably 60s, 70s. And then the first browsers were actually reaching out to individual computers and reaching information from there. Then the data started being centralized, and the topology of network completely changed to those data silos. So what we are trying to do is we are trying to build an engine that would securely go back to the roots of internet and allow information to travel freely. And there are some prerequisites so that the agent can actually be a real owner of data. First of all, the agent has to have a control over access, right? So he can always have his own access, or she, and grant access to the others as much as they want. The second prerequisite is that, unfortunately, data has to be stored in the decentralized way, because if it's stored centrally, there will be always somebody who can put the hand on it and either change the data or restrict the access or even alter the data. So we know that it has to be decentralized. But then once we have the decentralization, we also have to have some kind of verification of integrity of data. Because if the data travels freely across different computers, there could be malicious users that alter the data. So what we need the data integrity validation engine. And that's what Holochain is. It's a distributed database with data validation. And how does it work? Well, obviously, peer-to-peer distributed database has already been out in the wild, in use for a long time in form of a blockchain. But is it really distributed? It is distributed in a form that the data is stored on multiple computers in the same manner. But then, is a state distributed? Actually, no, because they're all holding one state. And they're agreeing to one state across entire network. And now we're getting to those very interesting basic questions about the information. Is it really necessary for me, speaking to somebody next room, that entire China is validating that information? Probably not. Well, so what's the flaw? The flaw is that we're trying to create a central state stored in the distributed manner. While what we are saying is that we can create a distributed state where only data applicable to the event is stored on the computers. Which means that if I start chatting with my friends, it's only us in the group of chat. It's not the whole world validating it. So we don't have one global state. We have only local consensus. So the topology of Holochain looks like this. Each agent holds the data storage and the validation engine, which means that on my device, devices are obviously the interfaces between the electronic world and the real world. The device itself is doing the validation and the communication. It's not that me with the device, I go to some miners or storage or central database. It's me validating everything, and I'm going to show in details how it works. Now, the communication between two peers is going to be only stored, so the peers reach only the information that is actually important for them. I'm going to talk about it in details a little bit later. And this is the model of how the Holochain stores data. It is, like in every presentation, there's one slide that's way too difficult for everyone, and that's the one. So if you don't look at this first, you only look at that. Those are how the users store their data. So whenever I try to send the information to the Holochain network, I create my local chain on my local computer, and that is actually cryptography validated chain. This is why we are put in the same bucket as blockchain, because we also have the chains of blocks. But this chain of blocks is stored locally, and it's only for making sure that nobody can tamper with information that was previously written. Right? So this is my local source chain. It's on every device that I'm using, and it's cryptographically signed, each transaction, by my cryptographic key, which is my identity, which gives me a full control over my data. Then those agents interact through so-called DHT. So this is where the device is actually sending some information to the network. And this is how they communicate. So if me, as an agent 1, make a transaction with agent 2 by, for example, sending them a message, I put this message in my source chain, I send it through the DHT to them, and because I know who I'm sending it to, they receive it and write it into their source chain as well. So with the exchange of information like tweets, that probably would be the whole everything. But then let's say that we are talking about the financial transactions, which depend one on the other. The problem of double spending is that somebody has to prove that they didn't spend whatever they had already, right? So I have to validate whether what they're sending me, which would be their balance, is actually valid. So this is where the validation starts playing part. So if I send an information, a transaction to user C, then the user C also receives the information, but that information depends on other previous information. So he sends out the request to DHT and says, can anybody prove that what this guy is saying is true? And then the user B shows the transaction. Yes, this transaction happened before with me. It's all fine. And how does it happen? Well, because Holochain is an engine that executes the code. So if whatever rules I put into that code become the rules of the network. To make it easier on the example, let's say that I write an application where I can send tweets, and the tweets always have to be about cats. So I tweet, I write the message about cat to my source chain, I send it to DHT, and this is where the validation comes in. Whoever stores the data, which means, because what is DHT? The DHT are computers storing a piece of information. It's distributed hash table, which means the information hashed is stored locally on the computer. Whoever becomes a storage of the information has to run the code on that information and check whether it's valid or not. How do they know that the code that they're running is exactly the same as my code? Well, because we are hashing the code, and the hash of the code says, OK, this is what I'm running on my computer, and it's signed by the private key, so it's verifiable. So if I make a transaction, or if I send an information, inside of the net, inside of the realm of the computer program that requires the word cat to be inside, I send it to the computers. Some of them have to store it, and whoever decides to store it has to validate it. They run the validation. They say, oh, OK, there was a word cat. Great, I can store it. So next time somebody requests the information, they can be sure that this information actually adheres to the rules of the program. Now, what happens if I write a tweet without cat about dogs? Whoever receives that information runs the code, sees, oh, there's no word cat. And then they say, this is wrong. Whoever wrote it, they send a warrant to the network that says, this guy is lying. We don't want to have him in the network. And then depending on what is written into the code of the DNA, we can decide whether we're like expelling that person from network. So basically, we're blocking communication with them. Or we just say, you can up to 10 times write about dogs, but then once you write the 11th time, we're kicking you out of the network. And it's very simple to kick somebody out of the network because you just block their public key, which means the messages signed by this public key will never be accepted by any of the network, which means there will be no communication, right? Okay, so that's the basics how Holochain works. And what consequences does it have? It has the consequences that each DNA actually creates a separate network. So I will write the code that wants me to talk about cats. I write the code, I hash it, it creates the hash. Everybody on the network knows with which application they are interacting through that hash, because they have to download this code to their local Holochain instance for being able to verify the information. Now, I can also write a second application that is about the dogs. Obviously, the hash of this code will be completely different. which means whoever downloads it to their Holochain will be participating in a different network that will be communicating through a completely different DHT, which means we can create as many specific code-specific networks as we want. So we have a very nice advantage first that each DNA forms a separate network. Now, DNA obviously is cryptographically verified, which means that we know that whatever code we're executing is actually the code that we should be executing. Then each participant of the network is running the verification code. That allows us not to have any trusted special entities. That says that everybody who participates in the network actually gives back to the network their computing power. So there is no place for miners. There's no place for like huge centralized data centers that race to create the block, to mine the block. But we have the network that's supported only by the users. And in DNA, in the rules, we can have whatever custom validation rules we want, whatever violation responses, and we write it inside of the code in the form. Whenever I receive the package, please check if there is something in it. If the package does not contain that, then send a warrant. If there are too many warrants, then say something, right? And also, okay, another very interesting thing is redundancy. So, as a user, I create a piece of information, like block H2, for example, and I send it into the DHT as a public record so that everybody can read from that. Who stores that, actually? Well, it's going to be stored by up to number of the nodes that I define in my DNA. So DNA is read by the networking module of Holochain, and this networking module knows I have to be sure that at least 10 people on the network maintain this information. Redundancy. Or I can say every single person on the network has to have this information. Well, that creates an exponential growth of the data. So as the participants were joining, it would be really hard to maintain. This is why we have the notion of redundancy, which means we will store the copy send only on 10 nodes maximum, or only on 20 nodes, depending on our redundancy level. And the network obviously has to talk to each other. This is the hardest part in our project, where the networking has to be kind of aware what nodes are actually in the network and which ones are not, because it has to continuously maintain the state of redundancy. Okay. Is that understandable, what I was talking about? Yes, okay, great. So what happens here is that, as I said, each code is creating a separate network, which means that I can have one DNA that's responsible for my tweets. It will be my tweets with my buddy, Hub2. I can have a DNA that's responsible for my position on the maps. So I basically send every 5 minutes my position on the maps. This is, let's say, green part. And I can have a DNA that speaks about my financial transactions. So it says what is the balance of my account. And this is my transacting through this network. Look that if one day I decide that I'm not anymore interested in my position, I just disconnect from the node. What's more, I just delete the DNA code from my computer, and I stop communicating in the map network. What's even more interesting, if two other users one day decide that they are not interested in knowing the position on the map anymore either, it disappears. It's a self-cleaning network. If nobody's interested in the data, then data stops existing, right? Then I can have different redundancy levels, different validation rules on each of those networks. With the money, I probably want to have it like very well verified, so I'll have redundancy level of 20, 30. But with my chats with my buddy, if it's only two of us, redundancy of one is enough. Well, if one day we lose chats, if we think so, then that's fine, right? So this actually creates a model where the RESTful API wasn't working, because I now have access to all those different services which are created by me, and I own the data. And that allows me to create RESTful applications, actually even more than RESTful because they're really RESTful, and cross-reference the data between data from each of those little hubs. Now A, B, C, D, E, F, G start being applications with the user-centric ownership of data. And the way we're developing Holochain is that what we are trying to do is build an engine where coders can create DNAs, and those DNAs posted into the public repository, which can be GitHub. We are trying to build like a distributed hub store. Could be downloaded into the instance of Holochain of every user. So for example, me as PJ, one day I would say, I actually want to start discussing about the life of cats. So what I will do is I will download this DNA from the repository, install it locally, and because this DNA has a certain hash, it will start communicating with other computers in the world that already downloaded that. So that way I automatically start participating in the network of talking about cats. And so our goal in Holochain is to create an engine where the community would pick it up from there and start writing the DNAs that will be downloadable. And then what is even more interesting on top of that is that DNAs itself are only data interfaces. So they allow data to communicate. But then you can connect to that the UIs, because this is the Holochain networking. This is my source chain. This is my data interface, which is DNA of an application, right? Which I ping from the UI like regular software. And my UI can combine it and really create fully user-centric applications. So you can actually, in our dreams in the future, create a user interface. Imagine you open in the browser your own local website where you have in this window information from that DNA, in this window information from that DNA, and you're not fed things that you don't want. By modularity, you're allowing yourself to fully 100% create what is your experience, what you want to see as your experience with data in the world. A couple of harder things in this approach are that, as I said, we are using the cryptography for signing messages. So a regular user that is not cryptography savvy would have problems how to even start, right? Because you have to create a key. I think on Ethereum network you need 28 steps now to even be able to post the first transaction. Well, we're hoping to minimize it to basically one login step with the Holo network. That would be the bridge into the Holochain, which you basically go to the URL like myhub.com, and then you log in and start using distributed applications. Yeah, that's quite a long way. Oh, thanks a lot.